Okay, so in the previous video, diniscuss natin yung continuity from the left and from the right of a certain value. Now, another related concept would be continuity on an interval. So let's look at the definition of what it means to be continuous on an interval. Okay, itong number 1, kaka-define lang din natin to kanina. So a function f is said to be continuous everywhere. So we just defined this when we define continuity. So continuous siya everywhere if it is continuous at every real number. Okay. And then continuous naman on the open interval a and b. So dito hindi kasama yung values na a at b. And continuous ang isang function on an open interval ab if it is continuous at every point or every value, in other words. So every number inside this interval. Now, number 3. Okay, this is related to number 2. So, ang difference lang dito, sinama natin yung left endpoint ng interval natin. So, kailan natin pwedeng isama itong left endpoint kung continuous din tayo from the right of A. So, kung andito yung A at andito yung B, ayan, tapos continuous yung function natin on that interval. So, lahat ng mga numbers dito ay continuous yung function natin. Now, pwede nating isama yung left endpoint na A if yung limit galing sa kanan ng A ay, if yung function natin ay continuous from the right at x equals A. So, number 4, continuous on the interval a to infinity if it is continuous at every x greater than A. And then number 5, similar to number 3, we can add the left endpoint if f is continuous on the interval from a to positive infinity and also from the right of A. So yung continuity on all the other kinds of intervals, for example, ito, and ito. So analogous lang. So halimbawa itong interval from A to B but you include B, okay? A function will be continuous here if it is continuous on the open interval from A to B, and also it is continuous from the left of B. Ito namang closed interval from A to B, continuous yung function natin dito. Kung continuous yung function sa open interval na A to B, at the same time continuous siya, ayan, sa kanan ng A at sa kaliwa ng B. Ayan. So similarly for this interval and also this interval. So let's look at some examples. Okay, so some examples. Well, we already know this. F is continuous. Well, let me use a different letter. P of x. Okay. Polynomial functions. Maybe I'll just write polynomial functions. The polynomial functions are continuous everywhere. How about the function f of x equals square root of x? Okay. So, we have, well, alamin muna natin kung saan defined itong function natin. So, it is defined when x is greater than or equal to 0. So, f is defined on the interval 0 to positive infinity. Okay. Now, it does not mean na defined yung function natin dito ay continuous na rin siya dito. Kailangan nating i-verify yung endpoint natin, which is x equals 0. So the function will be continuous on this interval if it is also continuous from the right at x equals 0. So can we actually approach 0 from the right? Well, yes. When x is approaching 0 from the right, x is taking positive values, which are close to 0. Dahil positive, defined yung mga square roots nila. So yes, so f is continuous from the right at x equals 0. Therefore, f is continuous on 0, positive infinity. Now, on the other hand, if I define a function f of x, which is equal to square root of x when x is positive, and then 1 when x is equal to 0. Okay. So, unlike the original function na square root of x, yung function natin na g of x, hindi na siya continuous from the right at x equals 0. Since at x equals 0, yung limit natin ay equal to 0, pero yung value ng function ay equal sa 1. So this function g is defined is continuous. So g is defined on this interval, but it is only continuous on the open interval 0 to positive infinity. Now, how about the floor function? Let me just show the previous computation. Ayan. So, na-compute natin na when x approaches n from the right, okay, from the right, then the function will be continuous. So the floor function is continuous from the right at x equals n. Okay. Now, dahil ganito nga yung itsura ng function natin, it is separated. It consists of separate portions. Okay. So continuous lang tayo dun sa portions na meron tayong connected portion ng graph. For example, this. So if this is n, then the other endpoint will be n plus 1. Okay. So we need to consider the interval n to n plus 1. So alam natin na yung floor function ay continuous from the right of n. So definitely isasama natin yung n. Pero hindi natin pwede isama yung n plus 1 kasi kung if x will approach n plus 1 from the left, okay, yung limit will now be different. The limit of the function will now be different from the value of the function. So ito lang yung interval on which the floor function is continuous. So is continuous on n. So the interval n to n plus 1 including n but excluding n plus 1 for every integer n. And another example, let's consider h of x is equal to x minus 2. So definitely the function is not continuous at x equals 2, but is it continuous on the intervals which are formed using 2, x equals 2 as a boundary? So yun ay ito. This is negative infinity to 2. And then on the other side, we have this. Oops. Okay, we have this, which is 2 to positive infinity. Okay. Now for this interval, Well, syempre hindi natin pwede isama yung 2. Okay. But we can take values which are less than 2 because the denominator will not be 0. So same thing for this interval as well. So h is continuous on negative infinity to and to positive infinity. Now let's go back to examples 3 and 4 because we have several intervals on which the function is continuous. Dito sa number 3, which is the floor function, we actually have infinitely many intervals of the form n to n plus 1. And dito naman sa h, we have 2 intervals. Ito, negative infinity to 2, and then 2 to positive infinity. So the question now is, if a function is continuous on 2 different intervals, is it continuous on the union of the 2 intervals? The answer to that is no. So let's just write that as a remark. So remark, okay, if f is continuous on A, so some set A, and B, so another set B, f is not necessarily continuous on A union B. Okay. One counterexample would be the floor function. Okay. So the floor function is continuous on the interval n to n plus 1. Kapag kinuha natin yung mga union nito, itong mga interval na to, over all integers n, we will just get the entire set of real numbers. And the floor function is not continuous everywhere. Okay. So that's one counterexample. A function which is not a counterexample would be h. So h is continuous on negative infinity to 2 and also on the interval 2 to positive infinity. Kapag kinuha natin yung union nila, continuous pa rin yung function dun sa union na yun. And the reason why is yung number 2, which is an endpoint of the interval, yan, is not included on the interval where it is continuous. Kasi nga, x is not continuous at 2. Pero dito sa f of x, the floor function is not continuous at n, but it is continuous on the interval from n to n plus 1, including n. Okay. So medyo tricky minsan itong continuity on a certain interval when the function is not continuous on an endpoint of the interval, in this case n. Okay. Pero when we say that the floor function is continuous on this interval, hindi naman natin ni-require yung continuity on the left and continuity from the left and continuity from the right na parehong mag-hold. Ang ni-require lang natin ay yung continuity, yan, from the right of n. And that's the reason why we included this interval. Okay. So again, it does not mean that the floor function is continuous on every element of this interval. For the endpoint n, it is not continuous on m. It is only continuous from the right at x equals n. So if f is continuous on an interval a b, for example, f is not necessarily continuous, ayan, at x equals a. So ganun din, if I include b in this interval, it does not mean that f is continuous at x equals b. And then another one, well, we're already listing several remarks. Might as well write remarks here. So yung interval or yung set on which a function is continuous, lagi siyang nasa loob ng domain ng function. So if f is continuous on some set S, then S is inside the domain. Hindi siya pwedeng lumabas ng domain kasi kung nasa labas na tayo ng domain, hindi na defined yung function. Hindi na rin siya continuous. So let's look at an example where we find the largest interval on which a given function is defined. Okay, so find the largest interval or union of intervals where f of x, which is equal to square root of 9 minus x squared, is continuous. So let's examine this function. So from the remark earlier, yung set on which the function is continuous is always inside the domain. Pwedeng equal sa domain, pwedeng mas malit sa domain, but it's always inside. Okay. So one thing that we're going to do is look at the domain and then see kung alin dapat nating tanggalin. Okay. Kung meron ba tayong dapat tanggalin in the first place. So ano ang domain nitong function natin? Okay. So meron tayong square root function. Dapat hindi mag-negative itong nasa loob natin. At magne-negative yan kapag yung x natin ay mas malaki sa 3. Kasi kung mas malaki sa 3, yung square niya mas malaki sa 9. Ganon din kung yung function natin ay mas maliit sa negative 3. Kasi kung mas maliit sa negative 3, yung square nun, mas malaki sa 9. Okay. And in those cases, magiging negative ang 9 minus x squared. So, pwede lang tayong manatili sa loob ng interval na negative 3 to 3. So, this is the domain of the function. We know that inside this domain is the interval on which the function is continuous. Okay. Now, continuous naman yung function natin for any number in the middle of negative 3 and 3. So, ang tanong ngayon, isasama ba natin yung negative 3 tsaka 3? Okay. Now, para isama yung 3, we need to check kung continuous tayo from the left at x equals 3 or from the right at x equals 3. And the answer, of course, is yes. Continuous tayo from the left at x equals 3. Okay, yung limit natin is equal to 0, which is square root of 9 minus negative 3 squared. Ganun din kung galing tayo ng kanan. So therefore, yung buong domain is also the largest interval on which the function is continuous. Okay. So f is continuous on the interval from negative 3 to 3. Now, let's have another function. It's similar to f. Pagbabaliktarin ko lang yung x squared tsaka 9. Let's find the largest interval on which this function is continuous. Okay. Since, again, may square root tayo, define lang yung function natin kapag hindi negative itong x squared minus 9. So, dapat yung x squared natin mas malaki siya lagi sa 9. Okay, so mas malaki lang siya sa 9 kung nasa labas tayo nitong interval na to. Pero pwede nating isama yung negative 3 tsaka positive 3 since defined pa rin yung function natin when x is equal to 3 or positive 3. So yung domain nitong function natin is negative infinity to negative 3, including 3, union positive 3 to positive infinity. So that's the domain. Now the question is, should we include the endpoint, which are negative 3 and positive 3? So we will include negative 3 if the function is continuous. On the left, at x equals negative 3, well, it is continuous. The limit is equal to 0 and the value of the function is also equal to 0. Kung galing naman sa kanan, yes, the limit is also 0 and the value of the function is also 0. So f is continuous on the union of these two intervals.